Students, I'm going to begin this third lesson in sequences and series with a screenshot from the textbook, the one that is online for you if you on your portal if you'd like to see it, but there's so few lessons that come from there that I hate to bother you with it. But here's a screenshot if you want to still this and write it down. But here's the one that I mostly want to talk about. Looking at this equation right here. This is the one that you're familiar with from last year to find a term at any position. And that's what it means. A term, A sub n, means a term at any position is equal to the first term, A sub 1, plus the common difference times the position right before it. So that is something that you learned last year. I tend to prefer to use slope-intercept form, y equals mx plus b. Let's look at the relationship between those. Notice that you have a common difference on the one on the left. A common difference is the exact same thing as a slope because they're both linear. And they're both linear because it is a common difference. It's repeated addition. So it lends itself to a line, not a curve. Also, the one on the left makes an emphasis of the first term. It puts a huge emphasis on the first term, whereas slope-intercept puts an emphasis on the zero term. When the x is 0, what is the y? It's a y-intercept. So that is the similarities if you ask me to compare and contrast those two equations. I just did that pretty quickly. This is the formula to find the sum of a sequence, also called a series. And let's interpret this in English. S sub n means the sum of n numbers is equal to n times the first term and the last term divided by 2. That's a little hard to memorize, so I submit to you what I like to remember. I like to say that if you're taking the first and the last and dividing by 2, you are looking at the average of those two numbers, right? If you add two numbers together, divide by 2, that's their average. And the symbol for average or mean is x bar times how many numbers there are. Now, when I put the x bar, it's not that you assume I use the first and last. That x bar stands for the average of all the numbers. And you may think that it's harder to find the average of all the numbers than just finding the first and last dividing by 2. But actually, those are the same thing. Again, let me repeat that because that's an important concept. When numbers are evenly spaced apart, like they are when you have this common difference, they're evenly spaced apart, their central tendency is the same. If you take the first and the last number and divide by 2, that is going to be the exact same value as if you added all the numbers and divided by how many numbers you have. So let me show you what I'm talking about. Now before I do, let me just scroll through these screens and say that in our next video, I'm going to show you how to answer questions that have to do with sequence, things that look like this, and then graphing the sequence, what that appears to be, writing a rule for the nth term, and writing a rule when you're given the graph. Then we will solve these. And students usually freak out when they see this. They're like, I have no idea what that is. You actually do. And I'll show you. You just never have not, I don't know that you've never seen it in that context. You probably have not seen this in that context. But I assure you, you know how to solve this problem. This is what I want to emphasize right now. This is called, this E, and I know I make mine rather ugly, that is called the sigma. That's actually big sigma, which means the sum of. It's a Greek letter. The sum of. And we're going to use this in our math, not so that we look smart, but because it's an effective way to say, add up all these numbers. So I'm going to begin by giving you, I want to show you the principle before I teach you the particulars. So I'm going to start with the number 2. I'm going to create a sequence for you, and I'm going to add 3 each time. I'll do 2, 5, 8, 11, 14, 17, 20, and 23. I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. If I asked you, I should have put a plus in between them, but I forgot. If I asked you to add all these together, most students would just start adding, but no. Look, you can take the first and the last, and that is 25. Next to the last and the second, and you get 25. 1711. Oh wait, 17:8. Sorry, it's 25, and 1411 is 25 for a grand sum of 100. Now they each come to the same sum because they are evenly spaced apart. And you may have heard of I'm sure that you have, when Gauss, his famous adding the first 100 terms together when his teacher was trying to get him to leave her alone. And if you haven't heard that story, let me know and I'll tell you in class. So the sum of these is 100, but this is a point that I want to make. If I looked at the average of this entire set, well, the average of the first and the last, 25 divided by 2, is equal to 12.5. The average of each pair is 12.5. Look at the average of the entire set. If I added them together, and there are 100, and I divide by 8, it is 12.5 because they are evenly spaced apart. So finding the mean of a set of numbers is simply found by taking the first one and the last one and dividing by 2. You have the mean for that entire set. Well, let me not erase this. I started to erase this, but I want to make a point. I just drew that equation, or that expression. Let me emphasize what I'm talking about. I have big sigma, and the bottom number that you see is called the lower index, and that's why you see it says I equals 1, because it's an indices. And this, oh sorry, my dog just put his, hey Jake, head on my arm, meaning I want to go to bed. I know you do, baby. Be there in a minute. Okay, this is the upper index, and this is my rule. Oh, Jake, here, come here, baby. All right, so we have the upper index, lower index, and rule. The lower index simply means, hey, this is the first term you're going to use. That's the term you begin with. I shouldn't say first term. I should say term you begin with. And the upper index is the term that you end with. And the rule is the formula that you're going to impart. Let me be specific and give you an example. The dog won't stop. Okay, if I put this here and I have 1 and 8 and 3n minus 1, I prefer n to the I. Here's what I'm going to do. So watch these steps. I take the lower index and I plug it in. The 1 is my first term position. So 3 times 1 minus 1 is 2. Now Brooklyn showed us that anytime you're looking for the first term, all you have to do is just, because if n is 1, then the coefficient stays as it is. And it's just 3 minus 1 is 2. So hats off to Brooklyn for being so efficient with numbers and looking at relationships between numbers. And now, so that's my first term. The last term, or I'm sorry, the 8th term, I plug the 8 in because that's my term position. N means term position. I'm looking for the 8th term position. 8 times 3 is 24, minus 1 is 23. So my sum is 25, and I divide by 2. And no, I do not turn that into a decimal because it's so much easier not to. Now I need to find out, now that's my x bar, right? My formula is x bar times n, how many numbers there are. And this is what you do every single time to figure out how many numbers there are. You take this upper index minus the lower index plus 1. 8 minus 1 is equal to 7, plus 1 is 8. So I'm going to take 25 over 2 times 8 over 1, and I'm going to cross reduce. Now you see the beauty of not turning that into a decimal. If I take 2 divided by 2, it becomes 1. 8 divided by 2 is 4, and the sum is 100. And I'm done. That's all I need to do. Now I'm sure that somebody out there is screaming, saying, what? No need to scream at me. we can do another example, because you know how these things tend to clear up once you do them a few times. You just have to hang in there and not complain. Let's do this one. This one's, ooh, I don't want to use I. Why do they do, well, I know why. Negative 2n plus 14. So, step 1, plug the lower index in. And you don't have to, because you know the Brooklyn method of negative 2 plus 14 is 12. First number is 12. Now plug in this number. 20 times negative 2 is negative 40, plus 14 is negative 26. And no, we don't care that it's negative. It still works. Add those together, and I should get negative 14. Is that right? 20, difference is 4. Yeah, negative 14. But I must do what? I must divide by 2. So don't forget to, sometimes I do, I forget to divide by 2. It's negative 7 is my x bar. Now I need to find how many numbers there are. And I take 20 minus 1 is 19, plus 1 is 20. Now I'm sure that people out there are going, why don't you just use that top index? Because the bottom isn't always 1. Sometimes they'll put a 4 or a 10 or a 12. So get into the habit of finding the difference and adding 1. What is 7 times, negative 7 times 20 is negative 140. And sure enough, if you add all those numbers together, you do get negative 140. So there, we've done that one. Let's do another. Is it getting clearer, hopefully? Here's my sigma. Yes, I know that I do it ugly. I'll start with a 3. And I'll go to a, I don't know, 20. And I'm going to use 3n plus 5. Okay, step 1. If you want to pause this and try it yourself, that's awesome. And then just turn it back on a second. I'm going to plug the 3 in, the lower index. 3 times 3 is 9. 9 plus 5 is 14. So I know my first number is 14. Now I'm going to plug this in for the last value. 20 times 3 is 60. 60 plus 5 is 65. And then I add those together, 9, 7, and I do 79 over 2. Again, I don't like to simplify because I know I'm going to be multiplying. So 20 minus 3. I need to find out how many numbers there are. 20 minus 3 is what? 17. Plus 1 is 18. So I'm going to multiply this by 18. Don't panic. We're going to cross reduce. Now, 2 and 18 have a common factor of 2. So divide by 2, divide that by 2, and you get 9. So I just have to do 79 times 9. You can do it 2 ways. You can do 79 times 10. And then subtract 79, or you can just do that. 79 times 9. 9 times 9 is 81, yes? 7 times 9 is 63, plus 8, is that 81? Oh, no, 71. Okay, so it's 71, 711, I hope. I think so, because look, 79 times 10 is 790, and if I take 79 away, then it is, 711. So there we have our sum. I find sigma by taking the bottom, top, putting it in, divide by 2, and multiply it by how many terms there are. Now we're going to do lots of these practices in class, and I hope you took notes or at least tried to work along with me, and then you'll do rather well. Take care.